Look deep inside any computer, smartphone, or server bank, and you will find the invisible foundation of our digital world, propositional logic. This system operates by taking complex, real-world statements, say, "it is raining," and stripping away all the vocabulary. It replaces the entire sentence with a single atomic letter, like P or Q. Once you have those clean little letters, you can plug them into absolute mathematical rules. If P is true, then Q is true. If it rains, the ground is wet. It works beautifully for building circuit boards. But because it swaps entire sentences for opaque letters, it creates a massive blind spot. Propositional logic looks at the letter P and has absolutely no idea what the words inside it actually mean. Let's test this against a classic proof dating back thousands of years. Premise 1. Every man is mortal. Premise 2. Aristotle is a man. Human intuition immediately tells us the logical conclusion. Therefore, Aristotle is mortal. Now, let's feed that exact argument into our rigid, modern logic system. Every man is mortal becomes P, Aristotle is a man becomes Q, and the conclusion becomes R. Mathematically, this argument is completely invalid. It fails because it only sees 3 disconnected letters, missing the internal overlapping relationships between them. To save the integrity of our math, we have to crack open those atomic sentences and inspect the structural gears inside. We do that with a system called predicate logic. Instead of treating sentences as solid blocks, it zooms in to identify individual objects and the specific properties they possess. It works by mapping grammar to algebra. Specific nouns in the real world, like Aristotle, become individual constants, written as lowercase letters. Let's call him A. The verbs or properties attached to those nouns, like is a man, are called predicate constants. We represent those with uppercase letters, like M. By combining them, the blind statement, Aristotle is a man, transforms into a precise, targeted formula, M-A. With this, logic can finally interact with specific things in the world and the distinct traits that define them. But that raises a new problem. How do we mathematically write the phrase, every man? Every man isn't a specific person you can point to, so an individual constant won't work. We need an abstraction. So we introduce a variable, usually x. Think of x exactly like a pronoun in natural language, like he or it, a blank placeholder waiting for a value. And since a variable needs boundaries to be meaningful, we bind it using a symbol called the universal quantifier, written as an upside-down A. It simply means for all. Putting it all together, we can finally translate our difficult first premise. For all x, if x is a man, then x is mortal. This diagram illustrates exactly what our new logic achieves. By defining the properties of men and mortals as overlapping subsets, we can clearly see Aristotle sitting inside the set of men, which is completely swallowed by the set of mortal things. By scaling our math from specific named individuals to infinite groups, the glitch is permanently fixed. The proof is mathematically sound. With this new syntax, we can translate complex intersecting ideas at lightning speed. Some green dragon is sleeping snaps instantly into a precise nested equation.